been tracking and studying Comet 3I Atlas ever since. We're here today to give you the latest of what we know about Comet 3I Atlas and what we still want to know. But first, what is a comet? It's a small, natural, solid body that is a combination of rocky and icy material that evaporates as it warms when it's close to a star, like the sun. But to start with, I'd like to address the rumors right at the beginning. I think it's important that we talk about that. This object is a comet. It looks and behaves like a comet, and all evidence points to it being a comet. But this one came from outside the solar system, which makes it fascinating, exciting, and scientifically very important. This is only the third interstellar object like this that humanity has ever found. And a little bit more about the rumors. I think it's very important, and I'm actually very excited that a lot of the world was speculating about the comet while NASA was in a period where we couldn't speak about it due to the recent government shutdown. I think what I took away from that whole experience and watching that as we were working during the shutdown was just how interested and how excited people were about the possibility of what this comet could be. There was a lot of speculation about what it could be, but what I think is really awesome is that folks were interested in this incredible finding that we observed and that came from the heavens, and what that means, what it could mean about how magical the universe could be. It expanded people's brains to think about how magical the universe could be. And I'll tell you, here at NASA, we think that every day. And so it's really great that you were able to join us while we were, not able to comment because of the shutdown constraints about what that comet is, because we think the universe is a magical place, and we spend your treasure and we spend all of our time trying to make sure that we explore that and share it with you as much as we can. In fact, we want very much to find signs of life in the universe. In fact, just a few months ago, we were with you and we talked about what we think might be the signal from ancient life on the surface of Mars from our amazing machines that have been roving the planet for 30 years to look for those things. That is something that's really important for us to learn about and discover. It could be an amazing discovery if and when we can confirm that. But 3I Atlas is a comet. So my colleagues from the Science Mission Directorate will go through the images in detail. But just to give you a peek, here's one of the images from the closest physical instrument we had to the comet, from the HiRISE instrument on our Mars Reconnaissance Orbiter, taken on October 2nd as the comet sailed by at a distance of 19 million miles from the instrument. You can see that Comet 3I Atlas looks like a fuzzy white ball. That ball is a cloud of dust and ice called the coma, which is shed by the comet as it continues its trajectory towards the sun. I'll leave it to my esteemed colleagues to share further details, and I'd like to introduce you to the head of NASA Science, Nikki Fox.
Thank you so much. It is such a rare opportunity for us to be able to observe this interstellar comet. And NASA Science has been given this really, really exciting opportunity to do it, and literally from the moment of its discovery. Just like Amit said, comets are tiny cosmic snowballs, and by studying them, we can learn about the environment from, basically where they formed, where they came from. This one came from a different environment from our own. And so we're already starting to see some really interesting differences to comets from our own solar system. 3I Atlas, as you heard, is the third known interstellar object to pass through our solar system, the first one being identified in 2017. While these types of interstellar objects have long been predicted, we are just beginning to be able to find them thanks to the newest technologies with our network of Earth-based telescopes, which are designed to find small, fast-moving objects in space. The NASA-funded Atlas Survey Telescope, which made the discovery, is part of NASA's Planetary Defense Network. Our telescopes are always watching the skies to keep us safe, and in doing so, they occasionally make major scientifically interesting discoveries, just like this one. Right away, of course, NASA's Planetary Defense Coordination Office they studied it, and they established that 3I Atlas is not a danger to Earth. In fact, it's at least twice as far away as the distance between the Earth and our sun. On October 30th,
इसके साथ बड़ा मुंह प्यार बन गया इस वजह से फिर ये हमारे घर आना जाना शुरू हो गया।
कितनी देर पहले मुंह प्यार बना इसके साथ?
when it
7-8
crossed
माह
just
पहले। 7-8 माह
inside
पहले।
Mars's
आपकी
orbit,
मामा के साथ भी
which is
दोस्ती
why
थी?
the image
किसकी?
that Ahmed
जी
क्या किस किस्म की
just
दोस्ती थी
showed,
बेटा?
he noted it was the closest
बात का नहीं
instrument
मालूम।
नहीं पता।
physically
नहीं
तो आपके बाबा कोई जुआ
to the
वगैरह
comet
खेलते थे?
because the comet
नहीं
अमीर अब्बास
was
खेलता
right
था?
inside the orbit
उसका
of
भी नहीं
Mars.
पता मुझे
अच्छा,
खेलता
आखिरी बार आपके
Was
घर
on
में
the
क्या करने के
opposite
लिए आया
side
था
of the
वो?
sun.
जब ये सारा कुछ हुआ है
हम
क्या
घर
करने
नहीं
आए?
हम घर
कहाँ
नहीं
थे आप लोग?
हम
Which is
फ्रेंड की
about as
तरफ
far
गए थे।
away
फ्रेंड्स
as
की
our
तरफ गए
planet
थे।
can
इससे पहले
possibly
क्या होता
be
था ना?
पहले
from Mars.
अब समझ नहीं आता
Clear from the moment of discovery that the comet was going to pass on the opposite side of the sun from where the Earth is. However, it was also clear that its positioning behind the sun was going to make observations from Earth very, very difficult. And that is why we are so happy to have our incredible fleet of NASA science spacecraft all across the solar system. And boy, were they ready for this event. NASA's science assets on board our missions have provided the United States the unique capability to observe 3I Atlas almost the entire time it passes through our celestial neighborhood. Everything NASA science does is interconnected, and nearly 20 mission teams have been working together to really rise to this challenge. 20 mission teams, by the way, and counting. Everything we're learning about the comet is possible because of the distribution of all of the different instruments on our spacecraft with different capabilities. And I'll note that for some of them, we've even pushed our scientific instruments beyond their normal capabilities, beyond the things that they were designed to achieve to allow us to capture this amazing glimpse at this interstellar traveler. In other words, we can study this comet so well because we have many different assets in different locations, observing things in different wavelengths, in different ways, with different instruments, each set of observations providing a different lens for understanding objects in the sky. So NASA's science team has kept watch on 3I Atlas for nearly its entire journey through the solar system for the first time ever. So I'll just quickly go through the timeline of which NASA spacecraft have observed the comet thus far, and we're still going. There will be more opportunities to observe this comet as it continues its journey through the solar system, passing the orbit of Jupiter in spring of 2026. So the NASA assets that are gathering observations of 3I Atlas include Hubble, the James Webb Space Telescope, TESS, SWIFT, SphereX, Perseverance Mars Rover, Mars Reconnaissance Orbiter, MAVEN, Europa Clipper, Lucy, Psyche, personal favorite, Parker Solar Probe, Punch, Stereo, and ESA, NASA's SOHO mission. And I'll note that Parker Solar Probe's data were just downloaded yesterday, and indeed, we did catch several glimpses of this amazing comet. The scientific community is hard at work analyzing these images, and everyone, as always, is welcome to take a look. At NASA, we embrace open science. We make all of our data available to the public 24/7, and we invite, in fact, we really want you to tell us what you're observing and what you think about what we're looking at. We're still learning even about what questions we still need to ask. And this, of course, is the scientific process in action. All the data go to a public archive. We get those images as soon as we're able to from all of our eyes in space. As always, I am excited to see what new things we learn about our friendly solar system visitor in the days and, in fact, the years to come. So now I'm going to pass over to Sean. He's going to tell you about what our astrophysics missions have seen. They, of course, were some of the first things to look at the comet And images from several of them have been available since the beginning of the summer. So I'm going to ask you to set the stage for us. Tell us what we've already seen before we hand over to Tom to tell us all the new stuff. Take it away, Sean.
Thanks, Nikki. Happy to. To give you some background, NASA's astrophysics missions, like all our missions, they are designed to do things that would otherwise be impossible. In this case, our nation's space telescopes stare deeper and more sharply into the universe than any other observatories in the world. And that means we're often the first to follow up and study near-Earth objects or comets like 3I Atlas after they're initially detected. That same powerful gaze that lets these telescopes see distant galaxies, those little red dots you might hear about, they also allow us to observe details about objects like 3I Atlas a little bit sooner. And the earlier we learn about these objects, the earlier we can share this information with the world, including the science community and our partners across the planet that often have ground-based assets or other space-based assets, so that they can conduct additional observations with their telescopes. In this case, our astrophysics missions came together to take advantage of this rare opportunity to study this comet that came to us from outside the solar system. From our flagship space telescopes to smaller missions like TESS and SWIFT, they all have, as Nikki said, different complementary capabilities. They don't just do things that would otherwise be impossible. They do things that even our other great telescopes can't do. So every time we add to the fleet, we add additional capabilities that expand the realm of the possible. In this case, it let us refine the orbit of this structure early on, determine what its structure is and what its composition is, what it is made of. It's a beautiful illustration of why we have not just one space telescope, but a fleet of them, because every one member of that fleet specializes in a different kind of information, contributing a different piece of the puzzle to the total understanding we have from the fleet as a whole. So for example, Old Reliable, NASA's Hubble Space Telescope, celebrated its 35th birthday earlier this year. And not too long after that, in July, it looked at 3I Atlas, not long after we discovered it from the ground. At this point, 3I Atlas was about 277 million miles from Earth. And what Hubble's images revealed was a few things. First, a teardrop-shaped coma of dust coming off that solid, icy nucleus of the comet itself. From these data, astronomers were able to more accurately narrow a few things. Importantly, the size of the nucleus. We now know it's between, at that point actually, we knew it was between 1,400 feet in diameter up to as large as 3.5 miles in diameter. And Hubble also saw that the comet was losing dust. And not just losing it, but losing it at a rate consistent with other previous sun-bound comets that originated from within our solar system, consistent with the physics that we figured out from watching those objects. Now, the last thing Hubble did is it gave us a better understanding of the orbit of this object. Tell us not just where it was, but where it was heading, so we could point other observatories at it, such as the James Webb Space Telescope. We added this to our fleet early in this decade. We didn't have it when the last two interstellar comets came around. Now, what James Webb did, and its companion Sphere-X, which we only launched at the beginning of this year, is it added infrared observations. The power of infrared observations is these are colors we can't see. They're redder than what our eyes can detect. And infrared light is particularly good at helping us understand the composition of objects. We can see little molecular fingerprints from the things that the objects are made of. So with these infrared